Calculus 2 in college, and he had a problem like this on his quiz, and he had trouble solving it. So I just want to quickly go over it. The whole point at this level with integration is to have a set of formulas that you can transplant, that you can kind of take the place of what you're given, reorient what you're given into one of those formulas that's then easier to integrate, right? Our formulas are all equations that we know how to integrate, and often we're given problems that could turn into those problems, metamorphosize into those problems, into those sets of integration equations. So what does this look like? Does this look like anything to you? Immediately, what I see is a kind of x squared plus a squared scenario. So one of our equations is arctan, and we know that the integral for 1 over u squared plus a squared du is equal to 1 over a tan negative 1 u over a plus c. So that's a known integral equation. So if we can make this, what we're given on the quiz, look like this, then we can solve it, and the answer will look like this. So how can we make 4x squared plus 9, how can we dress it up so that it acts, so that it behaves like u plus a squared when we integrate it? And this is the stumbling block that often trips students up. So 4x squared can easily be rewritten as 2x quantity squared, and 9 can easily be written as 3 squared. So is there any difference between these, 4x squared and 2x quantity squared? No, because this becomes 2 squared x squared plus 3 squared. So 2 squared x squared is the same as 4x squared, just to lay it all out. So there is no difference in rewriting it. We're just rewriting it in another way. It means exactly the same thing. So once we understand that, it becomes a much easier problem. But there's still another stumbling block that happens for students here. So let's rewrite it. So we're going to integrate 5 over 2x squared plus 3 squared dx. Now, the issue is that the form we have that we're trying to make it look like has a u squared. There's no coefficient in front of that, within that u. We have to do a u sub so that we have a single term. So we're going to do 2x equal to u. And so then what's du equal to? 2 is equal to du dx, or 2 dx equals du. Okay, so we're going to rewrite this as 5 over 2x squared plus 3 squared, and we need a 2 dx, right? So times 2 dx. So once we do that, we need to add a 1/2 to the other side of the integral, right? Whatever we do on this side, we have to do on the other side in order to make it equal 1, in order for it to disappear. So now we're pretty much home free. So now we can just integrate this. Well, maybe I should spell this out. This becomes du. So now we have let's take our constants out. So we're going to have 5/2 the integral of 1 over u squared plus 3 squared du. And we know from our general form here, our parent equation, that this is going to be equal to 5/2 times 1 over a. So what's our a? Our a is 3, right? Over 3 tan negative 1. What's our u? Our u is 2x over a. Our a is 3 plus c. This 1/3 will become 5/6. when we distribute our constants. So that is the solution to the problem. We used a u-sub, and we used the knowledge that the integral of a 1 over u squared plus a squared scenario gives us an arctan. I have a student